So we've been talking about quadratics in vertex form for a little while now, and here is the form that we have. The vertical stretch or shrink is given to us by A. If A is between 0 and 1, then you have a shrink. If it's greater than 1, you have a stretch, and if there's a negative in front, then you have a reflection. Your horizontal shift is inside. It's the opposite sign of what you see inside because of this negative, and the vertical shift is on the outside. We're going to look at how the parabola curves, okay? And if there's a pattern that would make our lives a little bit easier and would make graphing just a little bit easier. What is the MVP, the most valuable point? That is the vertex. And in this case, it's 0, 0. So we're going to evaluate where are the other points. So I'm going to go 1 unit away from the vertex, and where is my next point? Right here. It's 1 unit above. We rise 1 unit. When I go to the left 1 unit away from the vertex, how much do we rise to get to the point on the parabola? 1 unit. So 1 unit away from the vertex, the rise is +1. 2 units away from the vertex, how much do we rise? 1, 2, 3, 4 units. And if I go 2 units to the left from the vertex, we rise 4 units. 2 units away from the vertex, the rise is +4. The vertex here is 3, -2. 1 unit to the right from the vertex, we will rise 1 unit again. And to the left, the rise is the same, 1 unit, so +1. And 2 units away from the vertex, how much do we rise? 1, 2, 3, 4. So 2 units away from the vertex, the next point is found 4 units above that, so +4. The vertex here is -4, -7. Let's check the rise. 1 unit away from the vertex, we rise 1 unit. 1 unit to the left, we rise the same, which is 1 unit. Let's check out 2 units away from the vertex. 2 units will rise 1, 2, 3. Again, 2 units away from the vertex, we rise 4. This is becoming quite the pattern. Let's try this one. Our vertex here is at 0, 1. 1 unit away from the vertex, we rise -1 because we've now gone down. So if you go down, the rise is negative. 1 unit away from the vertex, -1 is the rise. What about 2 units from the vertex? 2 units away from the vertex, the rise is -4 because we went down 4. And again, 2 units away from the vertex, the rise is -4. So it looks like H and K affect where we put the vertex, right? The horizontal shift and the vertical shift. But what is affecting where we put the other points? Let's try some more. The vertex here is 0, -5. 1 unit away from the vertex, we rise 1, 2 units this time. And 1 unit away, we rise 2. So the rise here is 2. Interesting. What about 2 units away from the vertex? 1, 2, 3, 4, 5, 6, 7, 8. 8 is the rise here. So 2 units away from the vertex, our rise is 8 units. The vertex here is 4, -3. 1 unit away from the vertex, we rise 2. So 1 unit away, we rise 2. 2 units away from the vertex, 1, 2, 3, 4, 5, 6, 7, It doesn't quite intersect until 8 units. Until we have risen 8 units. So 2 units away from the vertex. The intersection point is here, so that would be a rise of 8 units. Our vertex here is -3, 4. The rise 1 unit from the vertex is -2. 1 unit away from the vertex, we rise -2 units. Now 2 units from the vertex, let's zoom in to get that intersection point. We rise -8 units. Again, as you can see, H and K make up the vertex. So what is affecting the rise? Well, let's see what A is for each of these. A is the number that's being multiplied by the x that's being squared. The number that's being multiplied by the x squared here, there's no number written, so I know that A is 1. The number being multiplied in front, again, is 1. Here, A is 1. The number being multiplied by x being squared is negative. Number 5. A is the number being multiplied by the x squared. Number 6. Again, this number in front, A is 2. The number in front, A is -2. The number being multiplied by that x squared is A, and that is 1/2. So when A is 1, the rise away 1 unit from the vertex is +1. And the rise 2 units away from the vertex is +4. When A is -1, the rise 1 unit away from the vertex is -1, and 2 units away is -4. When A is 2, the rise is not 1 anymore, it's 2. And then the rise 2 units away from the vertex is not 4, but now it's 8. Again, the rise was 1, but now that A is 2, the rise is 2. And 2 units away from the vertex, because A is 2, the rise is 8. Same if you have a negative, except the rise is just negative. Here, A was 1/2, so the rise 1 unit away from the vertex was 1/2. And the rise 2 units away from the vertex, instead of being 4, as we see with our parent function, the rise 2 units away from the vertex was 2, which is half of 4. So once you find your vertex, A directly affects where the other points will be in context of the vertex. So when we go 1 unit away from the vertex, so 1 unit to the left or right from the vertex, we will end up rising A amount of units. When A was 2, we rose 2. When A was 1, we rose 1. When A was -1, we rose -1. So 1 unit away from the vertex, our rise is determined by A. 2 units away from the vertex, left or right, our rise, when A is 1, the rise is 4. When A is -1, the rise is -4. When A is 2, the rise is 8. When A is 1/2, the rise is 2. So the pattern here is that 2 units away from the vertex, we will rise 4A. What do you think it's going to be 3 units away from the vertex? 3 units away from the vertex, the rise is 9. 1 unit away, the rise was 1. 2 units away, the rise was 4. 3 units away, the rise was 9. That's because the parent function is squaring them. 1 squared is 1. 2 squared is 4. 3 squared is 9. What do you think the rise would be 4 units away from the vertex? 4 squared is 16. So it would be 16 times whatever A is. So let's try some of them out. The x part of the vertex is whatever makes this equal to 0. X plus 2 equals 0. To solve this, we'll subtract 2 on both sides, and x is equal to negative 2. That's the x part of my vertex. If negative 2 is what makes this equal 0, then when we plug in negative 2, we will be left with plus 3, our vertical shift, which is k, the y part of the vertex. So my vertex is negative 2, 3. Now what is A? A is the number being multiplied in front, and that is negative 1. So I'm going to plot my vertex at negative 2, 3. The x values that I'm going to use are to the left and right of negative 2. So to the left of negative 2, I have negative 3 and negative 4, and to the right, I have negative 1 and 0. The rise 1 unit away from the vertex is A. So 1 unit away from the vertex, we will rise negative 1. The rise 2 units away from the vertex is 4 times A. 4 times negative 1 is negative 4. That's how much you're going to rise 2 units away from the vertex. Negative 4. Let me show you how to graph it. 1 unit away from the vertex, we will rise negative 1, so we will go down 1. Go back to the vertex. 1 unit away from the vertex, we will rise negative 1. That's where my next point is. Go back to the vertex. 2 units away from the vertex, we will rise negative 4. 1, 2, 3, 4. Go back to the vertex. 2 units away from the vertex, we will rise negative 4. And how would we do that algebraically? Okay, we would take the value of the vertex, the k, the y value, and what do? We subtract 1. So 3 minus 1 is 2. 3 minus 1 is 2. And then we would, to get to 2 units away from the vertex, we would subtract 4. So 3 minus 4, negative 1. 3 minus 4 is negative 1. Now let's check, is that where our points are? Negative 4, 1 is here. Negative 3, 2. Negative 2, 3. Negative 1, 2. And 0, negative 1. We graphed it correctly using the value of A. We're going to check 2 of our points just to make sure. V minus 1 is negative 3, so I'm going to plug in x equals negative 3. And V plus 1 is x equals negative 1, so I'm also going to plug in x equals negative 1 right where you see this x in the original equation. And you can use a calculator to check those. We got it correct. Those are both 2. To find the x value of the vertex, we take whatever makes this equal to 0. I would subtract 2 on both sides. So the x part of my vertex is negative 2. The y part of my vertex is k, whatever number is here. Same as last time. So I'm going to plot that at negative 2, 3. The x values that I'm going to use are to the left and right of negative 2. So negative 3, negative 4, negative 1, and 0. To find where the other points are, we're going to figure out what A is. It's that number being multiplied in front, so 1/2. So the rise 1 unit away from the vertex will be A, which is 1/2. And the rise 2 units away from the vertex will be 4A. Ooh, what is 4 times 1/2? That's 4 over 2, which is 2. So 2 units away from the vertex, we will rise 2. 1 unit away from the vertex, I rise 1/2 a unit. Halfway. Go back to the vertex. 1 unit away from the vertex, we rise 1/2. Halfway up. Go back to the vertex. 2 units away from the vertex, we rise 2 units. 2 units away from the vertex, we rise 2 units. And here is my parabola. Make sure you draw arrows at the ends. Let's check algebraically. We need to take this number, 3, we need to add 1/2. 3 plus 1/2 is 3.5 or 3.5. And 3 plus 2 is 5. 3 plus 2 is 5. Let's check if those are the correct points. -4 up 5, yes. This one is -3, and the y value is halfway between 3 and 4, so that is 3.5, and so on. So to save yourself some time doing all the algebra, you can use the patterns of the rise to help you find the other points. And really, the only point you need to look for is the vertex, because everything centers around the most valuable point, that vertex, that MVP.